All right, so we're going to look to continuity now, and as a quick reminder, we say, so here's a definition, we say that f is continuous at some z naught in its domain if the limit as z approaches z naught of f of z is plug-in z naught. So, as examples, we know our power functions are continuous for all n and n. And in particular, as a consequence of this, polynomials are all continuous. And that was the content of the previous video where we looked at the power functions. We saw you could just plug in I. Okay, so now that's what it means for our function to be continuous. And there is a criteria for checking, and the criteria is kind of silly in your book. It's just unraveling what this means. So let's unravel it real quick. So in other words, one, the limit should exist. Well, in order to compute this and say that these numbers are equal, the left-hand side has to exist first. Two, the right-hand side has to exist. So you have to be able to plug z naught into your function. Fantastic. Three, now that you've established both of these exist, you check to see that they're the same. All right, so that was kind of silly. It's just unraveling what it means to check this. But let's do it. So what we're going to do is we are going to check the continuity of f of z is z squared minus iz plus 2. And we're going to check it. Your book does it at a particular point, but we're going to check it at anywhere. So at a random at some z naught and c. In particular, this function is continuous everywhere. There's no bad points. Okay. So we went over in the previous video how to use differentiation rules to break this up as the limit as z goes to z naught of z squared minus I times the limit z goes to z naught of z plus the limit of a constant. And in particular, we showed that these power functions have limit z naught, in this case z naught squared. That's going to be I z naught, and that's going to be 2. Great. So the limit certainly exists. F of z naught certainly exists irrelevant of what z naught is. There's no complex number that it doesn't make sense to square, where that you can't multiply by negative I, you can't add to a square, and you can't add to 2. No issues whatsoever there. And 3, we need to check that they're the same. Well, they're evidently the same. Look at them. That guy is the same as this guy. And this goes with what we said earlier. All polynomials are continuous. This is a polynomial function, and such guys are automatically, well, not automatically continuous, but we're going to use that they're continuous from here on out.